Same thing again. And again. And the last two. Done. Actually, it wasn't done. I've actually connected, I think, this one. Let's do this again. That's fine. And this one omnidirectional connect. Okay. So I'll just close that down. Now what I can do is I can go into control points here and I can modify it. And you can see it's actually changing these control points in this object. And I can go in here. I can go into the control points. And I can move those around, and you can see it's modifying everything. And actually you can see there's a bit of a mistake here with one of the control points. It's gone a little bit wonky. So I'll go for the control points, just show wireframe mode, and actually I'll tell you what it is. Yeah, we've actually accidentally wired up I think one of the controllers to the wrong controller, so it's actually caused the lattice to kind of become compromised in that particular spot. But anyway, we can actually see the kind of end result that we wanted in the end. So now we've got one lattice, or rather we got two lattices, but they're acting as if they're instanced. So we've actually managed to recreate that lattice on this object here. Now there is another way of actually wiring things up, and in many ways it's actually better than what I just showed you. What you actually saw there was with wiring, you can make mistakes. This is normal enough. And another problem with doing it the manual way by wiring is that it can take a long time. In this lattice we only had 8 points, so it didn't really take that much time. But let's say we had a really complex lattice and it had, say, 400 points. You know, it's going to take a very, very long time to wire up all of the controllers together. And as you saw, human error can creep in. So I'll show you a script that does exactly the same thing as what we actually just did there. And I'll just bring it onto the screen here. And I'll just quickly tell you what it actually does. If I break this down a little bit, you can see this a little bit more clearly then. This actually points to one of our boxes, and it's box 2. So it's the middle box. It's this box here. And what it does is, it points to the modifiers, it points to the Pt.2, and it points to the master node, which we saw the point controllers all hang from. Then it points to the control point 1, and it points to the controller on control point 1. And then what we do here is we then say the same control point controller in box 3, in box 2, that controller is equal to the same controller in box 3. And MaxScript is object oriented. So what that does is it means that when you say one controller is equal to another controller, it doesn't mean that it just passes the value from that controller into it. You know, if the controller had an X, Y, Z value of whatever, it's not going to copy those values across. What it's actually doing is it's saying that controller is that controller. So in a way, it's a very quick way of instancing controllers. You're saying one controller becomes another controller, and effectively it is instancing. So it's a very quick way of doing things, and there are some advantages maybe to wiring. For instance, you can put expressions into the wire dialog. But if you want a one-to-one relationship between 2 points and you want them to share a controller, the quickest way to do it is with a script. Now, I've used longhand to do this script, and you can see that it's very ploddingly saying, you know, point 1, then point 2, then point 3, then point 4, point 5, point 6, whatever. And, you know, that's fine, but it's pretty slow. So in a production script, what I would actually do is I would actually run through all of the points in that master node, and I would create an array out of them. And once I had that array, I would then iterate through that array and assign the controllers in that array to the mirror array for box 2. So we would use an if-then loop to actually run through all of the points. And the advantage for doing that is it would work on a lattice which had any number of control points. If it had 4,000, it wouldn't really matter. You could just click on a button and it would very quickly wire up those two lattices together so they shared all their points. So that gives you an idea of how you can actually wire things together in 3ds Max. And as you can see, it's an okay workflow. it actually does the trick, you know. It achieved exactly what we wanted to do. So let's have a look now at Maya, and we'll see in Maya how we can achieve the same kind of end result, but as you can see, we'll have a slightly different workflow. Okay, in this section of the chapter, we're going to look at doing the same kind of scenarios we've just covered in 3ds Max, but now we're going to do it in Maya. Now, as you can see in the scene, I've actually got 3 cubes made already, and I've tessellated them here along the x-axis, and that's just to allow for the deformations that I'm going to apply to them later. Now, over here you can see a UI element called the outliner in Maya, and that actually lists all of the objects in your scene, and you can see it's also got some sets here. And they're actually logical constructs inside Maya that allow you to group objects and to hide objects by creating groups like that. Now, you can see that if I look at this polycube here, you've got a plus sign next to it. And if you click on that plus sign, it actually reveals that inside Maya you can actually see much more clearly the transform node and the geometry node of each object. This is actually the transform node, and this is actually the geometry node. And in Maya, it's actually called shape. And the name, as you can see, is actually based on the transform node's name. So it'll be P-cube1 shape. Now, if I click on the transform node, over here you can see in this window called the channel box, we're shown the actual transform values. So we can see we've got a x value of 0, it's translated 0.5 on y, and it's translated 0.92 on z. If I click on the geometry here, it just gives you some information about the geometry. And as there are no actual editable channels there, your information is quite limited. Now, there is another window called the attribute editor, and this is much more verbose in the sort of information that it shows about our objects. So if I just reduce the size of this window slightly, you can see that I can click on the transform node here, and it's shown here in the attribute editor. And I can click on the shape node, and the same thing again. The attribute editor will actually focus on the node that we've currently selected. And you can see that in each case, if we do a select here, we've got sub-elements of that particular node, and you can go in here and change the various values. But we won't actually be using that in this particular example, so I can actually quite comfortably close that for now. So let's get on with the example. And obviously what we need to do is we want to apply firstly a lattice to this first cube and this third cube. So I've got this shelf up here, which is actually very much like the tool panels in Max. So I've got a lattice deformer here, which is exactly the same as the lattice in Max. And in this third UI window down here, which is actually the hypergraph, which as you can see is a schematic view of our scene, you can see it'll actually update as we do things. Now, in Maya, the lattice is actually treated as an object, and you can see we've got the base object, which is actually the original shape of the geometry, and you can see it's got this gizmo that fits around all our objects here. And then we've actually got the deformation lattice itself. Now, by default, you can see it's got 5 divisions here in its t-axis. So I'm going to click on that and just quickly scroll that down to 0, because we don't actually need any deformations in that axis. But we could do with obviously a lot more in the u-axis, so I'll just put that up. Not too many though. And maybe we'll just have one extra one in the s-axis. So now that I've got our lattice, what I'll do is I'll go into sub-object mode. That'll allow us to actually grab the control points of the lattice. And I'll just move these around and deform the boxes. Now obviously when I created that lattice I didn't have the middle box selected, so if we make any changes to the control points here, you'll see that as with our earlier example, we're just going to be leaving the geometry behind there. It's not going to deform. And what we're going to then show is how we can actually use the interface inside Maya to actually edit our scene structure and get that particular cube to take part in the deformation that this lattice has got defined here. So I'll just grab these here, move them up a little bit, just so that we haven't got any control points at rest. We've got a nice sort of shape. So there we are. We've got our lattice defined, and I'll just move this up. And what we need to do now is we need to get this cube here to become deformed by this lattice. Now what we'll do is we'll graph the structure that we have here on this cube first, and this will give us an idea of